Hello, I welcome you all to my YouTube channel. I hope you all are doing okay. So, many times we hear noises, many times we hear songs, but have you ever wondered what makes a music differ from the noise? Have you ever wondered how some sounds feel felt? We feel some sounds that irritating, but some sound very sweet. What is the amplitude of a sound? What is the frequency of the sound? What is the wavelength of the sound? What are these parameters? Hence, it may seem like a word amplitude means amplitude or wavelength is length of the wave. But if you dive deep into this topic, you will understand the beauty of sound. In this picture, you can see some zigzag lines. What are these lines? These are lines like zigzag. This is also a line, zigzag line. In this picture, also zigzag line. What are these lines representing? Hmm, this is lambda. This length is lambda shown on the screen. This is also lambda. This is the denotation for the symbol lambda. And this is also lambda. So, what is this thing? Basically, if when you will have trigonometry, you will come across a function called sine function or cos function. Okay, maybe or may it they maybe or may not be sine function, cos function, but they look like this. Let us read the definition of wavelength. It is written here that wavelength can be defined as the distance between two successive crests. Crest means the peak, the top of something, of a wave. Here we have to first choose the crest of the wave. This is the graph of a sound wave, and crest is this or this or this. So crest is from this point to this point. If you join, this length is called lambda. Here you can also see this is the wavelength. Lambda is the wavelength. Symbol of wavelength is lambda. This is the crest. Here also you can see this is lambda. Now if we go to this diagram, it is very short. If I zoom it in, this is the length called amplitude. Amplitude is the difference of base level to the highest point. If I show you the definition of, there is not a definition of amplitude, but you can see, understand that this length here will be the amplitude of the wave. And the third most important parameter is the frequency. Frequency, the unit of it is hertz or per second. Per second as the unit denotes number of times that a distinct part of a wave passes at a given point in 1 second. 1 by second is its unit. That means suppose wave is passing. After 1 second, this point is come to this point. That means the total one wave has passed. If total one wave has passed, then number of wave passed will be 1, and in 1 second if it is passed, then it will be 1 per second. Frequency of it will be 1. So there are three parameters: wavelength, distance, and amplitude. Remember my friends, wavelength, distance, and amplitude. Can you spot the difference between these two waves? First wave's amplitude is small here, and the second wave's amplitude is high. Though their lambda or their wavelength is the same, but the amplitude is high for this wave and low for this wave. You can see here, this is the peak, this is the throw, and this is amplitude, this is wavelength. Frequency I taught you. Now frequency, how to detect frequency. Now frequency is number of waves passed per second. Suppose this is time versus frequency graph, and here it is distance versus amplitude. You may also note what the graph is. It may be from time to this, from time distance to this amplitude. You have to understand what are the x and y axis. Now this is one wave and this is another wave. This one wave completes in this much time and this wave completes in this much time. If in a given time, if a wave takes larger time to complete, that means in a given time it will pass slowly. So its frequency will be smaller and the frequency of this wave will be larger. I hope you understood the point I was telling you. If yes, practice some questions. If possible, I will also make you practice some questions on this topic. So that's all for today. Thank you very much for watching. Enjoy. Goodbye.